Okay, so this time we will start our optional class, optional null-safe programming. So this one is one container that may or may not hold a value. It was added in Java 8 to represent might be absent explicitly in the type system. Okay, reducing the chances of null pointer exception or NPE. So think of exceptional as a box that's either empty or contains exactly one item. Instead of returning null and hoping the caller checks for it, we can return an optional that forces the caller to handle both cases. And we have one very interesting history for like this null object. We got this null reference in our 1965, and many call this one is like $1 billion mistake. So in our history overall, this null has caused more bugs than actual crashes. Okay, now next thing, the problem with null. Null references have been called the $1 billion mistake by their inventor in 1965. We got this null reference. So problem is simple. Nothing in the type system tells us a value might be null. So let's say we have this chain of methods. Then if any of these methods returning null or may return null, then we will get this NPE somewhere sometime, and we don't know like if we got here, if we got here, or somewhere else, right, in our code. This one is very hard to like find and like put conditions. Okay, so the problem is not that null exists. The problem is that our Java's type system doesn't distinguish between a string and a string that might be null. That's the problem. So for this case, we can handle something like this. Okay, this is one way, but let's say if we have other methods in our chain, then we have to write like more nested ifs, right? We have one better way, that is optional. Optional provides a cleaner, more expressive alternative. Okay, that in there we can also provide the backup value as well. Creating optionals. Optional.off creates an optional containing the value, throws NPE if value is null. Use this when you are certain the value exists. Okay, like that. Optional string name optional.off. Optional.off nullable. This one is the best choice. Creates an optional that may or may not contain a value. Returns empty optional if value is null. This is the safe choice when value might be null. Optional.off nullable. Get username could be empty. Okay. Third one, we have optional.empty. Creates an empty optional. Use as a return value when there's nothing to return. Okay, now next one we have checking and retrieving values. First, we can check presence by using name dot is present method, and we can see this one. Okay, that will be very interesting to see their implementation. If you can see here, this one will return just Boolean, and by just one simple condition, null check. Okay. Overall, we have so many methods here. Public, final class, optional, value based. Okay, then optional empty. Okay, value, we can get this. Empty, we have optional, we have off nullable, we have here. Okay, if we have null, then we will get this, we will return this one empty, and that is this one. Okay, of type null. All right, otherwise we will return the value which is wrapped with optional. Okay, that is one interesting thing. And then we have get is present, is empty, if present or else. Okay, that's fine. runnable we have here, empty action. So we can see some important methods. Okay, flatMap we have or stream. You can see this one, or else get, and or else throw. So these three methods are very useful. Okay. Getting values safely. If we call directly.get, throws no such element exception. After is present, check, avoid if possible. Now next one we have or else default, returns default value if we don't have like actual value in our optional container. Third one we have or else get supplier. Okay, call supplier for default, and or else throw no such element exception, or else throw X supplier throws custom exception. That's fine. So for or else get, we can say, let's say we have one type user, then we can call something like find user. We can assume some methods. Find user, then let's say we can find by using email. Then for backup case, we can do something or else get, right? And here we can provide our supplier, that will be our create default user. Okay. And you can also see this one. So we pass here supplier. Okay. Supplier.get. We can also see some other, like we don't have here actual class, so we don't have to create. I mean, we can understand just like this. We can also have here or else throw, right? So we can call for that user equals to, let's say, find user. We can pass email here, or else throw. Okay. This one also accept one supplier, and we can throw here new, let's say, user not found, and just put exception. Okay, like that. And also in this exception we can provide anything, our message. Okay, we can also see this one, right? No such element exception. We can pass here our custom exception as well from this one. Okay, and our this X must extends throwable. So for our custom exception, we will call this one. Okay. Otherwise, we can call without our custom exception as well. And in that case, we will return this one. No such element exception as our default inbuilt exception. Okay. All right, now we can see some other things. Or else versus or else get. So this one will evaluate your default value always, even if our optional has a value. And if that default value is, let's say, expensive in computation, then definitely we don't want to that like processed every time. Then we can use or else get. We have discussed this one in our previous chapters. This one is bad. You can definitely use or else get. This one will accept supplier. Now next one, transforming optionals. Map, transform the value. So let's say we have this optional type, object, and upper. So name dot map string to upper case. We can also change their type, right? That's fine. Like map is also like transformer. Chaining transformations, optional dot of this to then map, then to uppercase, or else. Flat map, flatten nested optionals, just same like our stream. To avoid optional of type optional, okay, we can use flatMap. Filter conditional value, we can use here dot filter, okay. And if you directly paint this one, then definitely you will get this optional dot empty you will get, okay. We have seen optionals to string method, right? Maybe we can see one more time. So if you come here and if you just filter this one, then you will come here. So for null values, we will get optional dot empty as returned string. Now next one we have conditional actions. If present, do something with value, okay. If present or else, handle both cases. We got this one in Java 9. If present or else, so if our value is present, then we will call this one, otherwise this one. Or provide alternative optional, also from Java 9. Or, so just change, okay. First we will check in cache, then in database, then in backup. So something like we can see. Now next thing, optional in practice as return type. The primary use case is signaling that a method might not return a value. Find user by ID. So in your method signature, definitely you can provide this one as your return type, so that when we will call this one or some other developer will call this one, can understand that we can get null from here. That's why we used optional. Okay, chaining method calls safely. Okay, optional dot of nullable, flatMap. Okay, that's fine. Now we can also use our optional class with streams. Filter out empty optionals and unwrap values. So let's say we have a list of optional like strings, then we want to filter out the actual values, right? So optionals dot stream, we can call here dot filter optional is present. Okay, this one is one predicate. And if we have like actual value, then we can call map optional get. So here we can call directly get, okay, because if we are reaching at this point, that means we have actual value, not null. So this one is safe here. Then to list, that's fine. Cleaner with flatMap, okay. Now some patterns to avoid. Using get without check. This one is problem. Always use like this condition before you are calling get. Optional as field. Don't use optional for class fields. It's not serializable and adds overhead. So we will see serializable in our next topic. What that mean? Okay. So we can skip this one for now, but just remember that this one is not a good practice. Even though, can we declare this? Let's see that. We can come here and so you can see we are getting one suggestion used as type for field middle name. This one is not recommended. So this one is not just that thing that we can use. Okay, we are getting one warning here, not error. Okay, if we compile this, then that's completely fine. Okay, just not a good practice. Optional as parameter, it's awkward and unclear. So mostly our use case for optional is in return types. Okay, our next pattern is, anti-pattern is wrapping just to unwrap. Don't wrap a value in optional just to immediately unwrap it. So here we are wrapping and here we are immediately unwrapping. This one is not good practice. Okay. If you have to immediately unwrap that one, then definitely you can do this one. Okay. Or this one. Optional versus null. When to use what? Method return type might have no result, then definitely optional. Class fields use null with optional getter. Method parameters overload or accept null. Collections empty versus absent. Return empty collection, not optional. Because we are expecting collection, then there is no point to change the type. Primitive values use optional int, long, or double. Okay. Then we have quick summary and we can move forward with our next chapter, which is collectors utility class.